Okay, so today we're going to look at doing some preparation of cultures on moldy slides. Here we have one bacterial colony that is grown on some agar, and it's grown on agar that is on a particularly thin plate. So when the culture dries, it's as smooth as possible for the imaging. And in a plate this size, that's typically around 14 mils of agar for the plate. What we have here are some conductive glass slides that we'll be applying the colony onto. And once it's on here, then we will dry the colony down once we've attached the sample. Just make sure it's up the right way, so the conductive side should be facing up, and on these Brooker slides you can just tell just the writing, you should be able to read it, and that's the top side. For the colony itself, you just need to open up your plate, and we'll be using these two tools here. So we need a scalpel to cut out where the colony is, and then this little spatula to scoop up the colony and then lay it down on top of the glass slide. And what we don't want to do is just to cut it out and put it directly onto this glass slide, because what will happen when it's in the instrument, the agar can start to flake off once it's been dried, and we don't want any little bits of agar inside the mass spectrometer. So to avoid that, we will first apply a very thin layer of glue across the surface of the slide. So what we're using is this type of glue here. It's like a little glue pen, and basically you just need to make a thin layer across the glass slide with this glue pen. So if we just take this, and you can just go right the way across, just do one streak and just layer up your streaks along here. And you can sort of see the application as you're going. And now there's this thin layer of glue right across that slide. We're avoiding the barcode and the numbers down the bottom here, because we won't be putting sample across that area anyway, because we may need that later. And also there's these teach points here. I have applied glue across them, but we'll also just try to avoid those spots when we apply the sample as well, because they're useful for when we're doing the setting up the acquisition later. So that's the glue applied. It can dry. It doesn't take long at all, and basically once it's dry, it can still stick your sample, so it's no problem. So you don't have to be quick about it in that sense. So now we have our colony here, and what we want to do is just cut out a square around the colony that we want to apply to this slide. And you should cut out approximately the area you want to actually image in the MALDI. So here we're going for the entire colony plus some of the agar, so we'll be able to actually image if any of the metabolites have been excreted out into the agar as well. And maybe you just overdone it, it's not quite square in the middle, so you can always just adjust this as well by just making another cut down, getting it a bit closer, and I think that there should be fine. And then we simply need to get the spatula now, and now the idea is we want to pick the colony up with the spatula and then lay it down on top of the slide. The easiest way to go about doing that is to, one of these sections where we've made these cuts, just pull the agar away from the section we want to actually pick up, and now we're down to the base of the plate, and then we can slide in under there and pick up the colony. And to do that, we don't want to damage the under edge of this colony so much, because basically it can crack the agar a bit, and then it won't dry completely flat as possible. So we want to go down low as possible and just like slowly edge the spatula under here just to lift it up. And something like this, and then we see we're just under there now, and just be really nice and careful and slow. Pull it through. And you don't have to go all the way through because it should just lift up slowly. And I've got my my hand on the plate here, so this is just one sort of component, so I'm not like, it helps stabilize basically when you're doing these really fine motions. So just lift it up like this, and then we want to apply it to the glass side. So we'll try to just go straight like this. So it's a good idea to place them with the side facing this way and go like this, because if you do multiple samples, you might want to do, say, 3 or 4 on here. So you don't want to be placing them over top of your other samples because you may interfere with your other samples. So just keep that in mind if you've got multiple on one side. Here it doesn't really matter, but yeah. And when we're placing it down, we just want to make sure we don't get any air bubbles underneath the agar. So it's sort of like a matter of getting one edge down and then slowly letting the agar fall down on top of the glass side without trapping air bubbles. So one way to help with that is you can actually go back to the scalpel and you can place it at the end of the agar and just pull the spatula out basically. And then the agar should just like naturally fall down on top of the glass side. You can see it there. Whoop. Out to the edge. Now we can see if I've done a good job or not. And it actually looks pretty good there. So when you place it down, you should always just hold it up to a bit of light and you'll be able to see if there's any air bubbles and things underneath the agar. In this case, there isn't any air bubbles, but if there are, what you can do is just come back in with the spatula and just like lift up the edge and then place it back down until there's no air, all the air bubbles are gone. And that's basically it. And now we'll dry this here until it's completely dried. And after that, we'll spray it with, we'll take a light image of it in the scanner and then apply the matrix for acquisition. So we have been drying this sample now, and you can see that it's really nice and dry, and it's very thin now as well. So it's dried completely thin, and it is it adhered really well with the glue as well. If you also, in the case if you wouldn't have used glue, the edges would have shrunken a lot as well. So the glue also keeps it in its original proportions. So with this now, we will take it to the computer and do a light scan of it, so we get an image, the base image of the sample before we do the matrix application and acquisition. Okay, so now we're going to make a light image of the sample, and to that we're going to use this scanner that we have over here. So to do that, we just need to take out the manifold and then place the side into this section. So to do that, we just have to pull back this like spring clip here and just set the sample down and then close the clip, just like that. So the sample should be facing up in this orientation, and this this spring just holds the sample in place, and then we can just pop that into that. Okay, so now that we have the sample in the scanner, now we just need to open this program called Tissue Scout, and just double click here, and hopefully it opens right. Yep. So before we can do an actual scan, it's grayed out, so we have to first do a pre-scan. So let's go ahead and do that. Okay, so you can see here in the pre-scan that we've getting these strange lines across the sample. That just means that we need to do a calibration on the scanner. So we'll just go through the calibration steps. This happens maybe every second or third time that you're running on the scanner for some reason. But basically we just do a calibration and then this will fix the errors in the image. So to do the calibrations, we just need to click here, calibrate, and just follow what it tells us to do basically. So it will do a little bit of a process here, and then it will tell us to remove the manifold from the scanner. And once that happens, then we can continue with the calibration, and then it's basically done. Yes, So this is halfway through the calibration now, and it tells us that we have to remove the adapter, what I was calling the manifold, and it won't let us click next until we actually remove it. So if we go over here, just remove this, we can now see we can actually click this next button. This, if you take it out and you still can't press the next button, it may be because this little door is stuck up. So if you can just give it a bit of a flick, you can get it down, and then you'll be able to press next. And so the calibration is now done, so just hit finish. And we'll now continue with another pre-scan. Now that we have the pre-scan done, you can see that it looks much nicer without those weird lines through it. Now we can actually do the full scan. So we click the scan button here, and it will ask us for a name to add to the image. So this should be your sample ID, starting with today's date, and then followed by the sample ID. So in our case, this is there, and then okay. So the main scan is now done, and it took, I don't know, about 5 minutes or so to do the whole slide. And now that it's done, we can just close Tissue Scout and go OK. And then we will just take this slide out of the manifold and get ready for applying the matrix. Okay, so now we have our, we've taken our light image of the glass slide. Now we want to put the sample in the sprayer so we can apply the matrix. So first of all, we just need to take off this window here and just place the sample in the back. And for one sample slide, I normally place it in the back right corner, just like that. And now we need to go into the software and show it our sample, where our sample is, and how we actually want to apply our matrix. So at the moment, it's set to this default 3 glass slides. So to help us out, we can just go to single glass slide, and it gives us this default spray area here. And for our sample, since it's only down one end of the slide, we can narrow this area a lot more and save on matrix basically. So we can do that by either adjusting the sample area or the overspray margins, and adjusting these will also just reduce the size basically of our spray area. But let's just start with this anyway. So you just, as you change these, you can see the actual spray area is actually changing along with it. But basically what we want to do is to move this right the way down this way quite a lot. So we can increase this X range here. And then, I mean, I typically actually like to set these oversprays to 0 and then just estimate the actual sample size, and that way you get overspray, but then you only really have to adjust one of these settings. So we want to adjust this to approximately where our sample is, and now I'll go a little bit over the glass side, and also a little bit over on this side as well. Here I won't bother going over the glass side here because our sample is actually in from that edge quite a bit already. But maybe we can increase the X a little bit, something like that. And this is going to give us good coverage of our sample. So once we've set our sample size, then we need to select our method. And today we will do this method here, this DHB on agar, and we'll be running with this, these are the sort of default settings for this method, which is saying what the solvents are, concentrations and things like this. But depending on your sample, you'll want to change the solvent that your matrix is dissolved in. You might want to change the type of matrix you're using and all these different things, the concentration of the matrix of course as well. Then there's also the number of passes, so this is how many times it's going to go over the sample. Other important thing is the temperature, because especially if you're using 100% methanol, if you have it above 60 degrees, it will start causing problems, because what will happen is when you're using 100% organic, the organic will instantly sort of vaporize as soon as it comes out of the nozzle, and you'll get this sort of splattering sort of effect. It's going to be uneven matrix application, but also matrix will start to build up quite a lot on the nozzle itself and cause other issues. So today we are actually going to be using 100% methanol, so we won't actually go above the 60 degrees. I think this is going to be where we'll cap it here. And we'll do, say, 10 passes for this, and our concentration is 20 micrograms per mil. The flow rate, typically we always maintain the same flow rate, and these other dimensions are what we're doing to adjust the matrix application. So things like the velocity, we normally also keep the same, but you could change the velocity to increase or decrease the matrix application to some degree. Same with the number of passes and things, and especially concentration as well. Yeah, and most of these other settings we typically maintain as they are. The pattern is just how it applies the matrix. CC means it's going to do up and down and then back and across, so like a checkered pattern basically on the application. But for us today, this should basically be fine, 60 degrees, and with these 10 passes. So now we can just go to the cycle, and in here, this is where we can see what the current status is. We can see the loop volume, so this is how much matrix is remaining in the sample loop. The sample loop is like the matrix loop, so how much matrix in the system that's ready to be applied. At the moment you can see it's 0, so we have to load our matrix onto the sample. And you can see here it also estimates how much matrix we're going to need for this particular run, and it's saying we need around 800 microliters to actually do this entire run for the matrix. We'll load in 1 mil total, so then we've got a bit of extra there just in case there's some losses or whatever along the way. So let's load the matrix. So here we have a matrix, and this is our syringe that we use to apply the matrix. So what we want to do is make sure this is in the load position. That means the flow of the pump will be bypassing this sample loop. So we can load in the matrix, and then without worrying about it being washed off the sample loop. So what we do is simply add in our sampling needle and our matrix here, and we want to draw up 1 mil. Just like that. And then just lock it in, and then apply our matrix to the sample loop. Okay, so now just like that, we have our 1 mil of matrix within the system. Before we can apply to the sample, we need to first turn on the pump, which is this button here, and it's already set to this default flow rate of 0.1 mils per minute. And it looks like we might have a bit of a problem with the pump. Okay, so when we turned on the pump, we noticed a bit of an issue with the back pressure. So you can see the back pressure is fluctuating quite a lot. So we're at 2, 4, and then sometimes it even jumps up to like 14, 20. It should really be at this constant value around about 30. It may fluctuate 3 or 4 bars, but it should be much more constant than what we have here. And what the problem likely is that there's air in the pump. And in some cases, if you just wait long enough, you'll see that it will stabilize, and then you're good. And in our case, this time it has actually stabilized by itself, so it's flushed that air bubble out of the pump, and we are actually fine to proceed. If that doesn't happen, there is this valve here which you can open and then increase the flow rate here, and that will help purge out any air in the system. And once you do that for say half a minute, a minute or so, you can close it again, turn down the flow rate, and try it again at this standard flow rate and see what happens. But this is exactly what we want to see in the back pressure. It may fluctuate. Okay, so now we have loaded our matrix and we've turned on the pump. So what we should first do is actually reset our matrix volume, so the system actually knows how much matrix we have in the system. and we loaded it in 4, so let's go ahead and put in, oh sorry, we loaded in 1, yes, very true. So let's change this to 1, and now everything's been reset. We have a loop remaining volume of 1 mil. And with that all in place, we can just click start. Okay. So, and now nothing really happens. So, especially if you're using a different temperature than what it's currently set to, you'd have to wait until that temperature is reached before you can actually begin. We're set to 60, it's at 59.9. This is close enough, we can actually run. You know this because the number is actually green. It would be red if it wasn't actually ready. And then we've clicked start, we're basically ready to go. The one thing we need to do is, it will tell you here in this prompt, turn valve to spray and press continue. So we don't want to press continue right now. First we want to turn the valve to spray so the matrix gets applied to the sample. So this is important now. So this is the unload, we need to turn it to spray. And that just opens up the sample loop to the flow of the pump. So we just turn this to spray, and then we can just go ahead then and click continue. For some reason I'm double clicking everything, but that's okay. Yeah, and now it's just doing this countdown. So this is a little countdown to load the sample loop into the line to the nozzle. So there's a bit of a dead volume there, so it sort of sprays out a bit of eluent before the matrix actually gets to the end of the nozzle. And once that's done, it will begin the method. And here we go. And the matrix application is now starting. And after the first couple of runs, you probably won't be able to see any matrix on the sample because it's so fine. But by the end of the sample, you should be able to see plenty, a coating across the whole sample. That's really even. And that's about it for sample preparation for MALDI. Okay, so now we can see that the spraying has completed. And you'll notice this here, it says valve load confirmed. Basically what it's saying is, if you look over here, it's telling you to turn a valve to load. So basically we're now isolating the matrix loop. And to do that, we just need to go down here and turn this back to load. And then we can say we confirm that we turned that to load. And now that's the spray finished. What we should make sure of is that there's actually no matrix left in the loop, so we've actually flushed out all the matrix out of the loop, and we still have the flow going on here. What we can do, and it's normally a good idea, is maybe to run this again for like 5 minutes, maybe even turn it back to spray, run for 5 minutes, just to make sure we're flushing out all the matrix out of the system. Because the matrix is at a very high concentration, so it can start to maybe precipitate and things if you're using different matrix compositions and solvent ratios and things like that. So it's a good idea just to make sure we clean out the system, because all we're pumping through here is methanol, so it's going to be good to flush the system out. So we'll just leave this on load for 5 minutes, and then we'll switch it back for 5 minutes as well, just to make sure that everything's done, and then we'll turn off the flow right here. Yeah, and then now that we have our matrix on there, now we can make sure our sample is dry. Ours will be dry because we're using just methanol at 60 degrees, so the sample is actually ready to run. If you're using a lot more water in your application, or you're doing a lot lower temperature, then you may want to make sure your sample is dry before, well yeah, you should make sure your sample is dry, and it may take an extra time to actually for your sample to be completely dry before you can run. But yeah, that's all for the sample preparation. So for the sample that we've just been preparing, we're not actually going to run it today, so we're going to store it for some time before we can run. And the best way to store this is actually to freeze them, but also we'd like to freeze it under a vacuum. So what we're going to do is put it into a glass slide container like this. We're putting it in here, closing that, and then put it into one of these vacuum seal bags, just like this, and then we'll vacuum seal it with this here. And this is just a cheap vacuum sealer from like a supermarket, and just make sure this is locked closed, and then simply just press the vacuum and seal button. So yeah, and now it's finished, because you can tell because it stopped pulling that vacuum, and after it pulls the vacuum it will keep going in a way because it will do the sealing, and you'll know when the sealing is done because the light will turn off. It's a really dim blue in the sun, but you can sort of tell if you put your hand up. But now it's all done, and then we can just click these two buttons on the side to release it, and there's our sealed sample that we can now freeze. So we'll just write the sample name on here and then put it in the freezer. When we're ready to run this, what we want to do is take it out of the freezer, let it get up to room temperature, and then open it. Because if we open it too soon, because it's cold, it will attract a lot of moisture onto the sample, and we don't want that. So just up to room temperature, cut it along here, and then we can take our sample out and run it.